Welcome to Biswanka's Math Exclusive. It is my part 3 video on successive differentiation. Today I start the Leibniz theorem. For better understanding, see my previous 2 videos. Now start with Leibniz theorem. Let y is equal to uv, where uv be the functions of x alone. Then differentiating we get y1 equals to u1v plus uv1, y2 equals to u2v plus twice u1v1 plus uv2 equals to twice c0 u2v plus twice c1 u1v1 plus twice c2 uv2. So we get yn equals to, that is nth derivative, yn equals to nc0 unv plus nc1 u n minus 1 v1 plus ncn u vn. This is the Leibniz formula. Now comes some example. Y equals to x square e to the power ax. Then find yn equals to what? Let u equals to e to the power ax, then u1 equals to a e to the power ax, u2 equals to a square e to the power ax. Similarly we get un equals to an e to the power ax, and v equals to x square, v1 equals to 2x, v2 equals to 2. We let v in such a way that the derivatives of v is 0. Here v3 equals to 0. Differentiating 1 n times with respect to x successively, yn equals to x square e to the power ax in the second bracket n. By Leibniz theorem, yn equals to 1 dot a to the power n dot e to the power ax into x square plus dot dot plus n into n minus 1 by 2 a to the power n minus 2 e to the power ax into 2. So we get yn equals to an x square e to the power ax plus twice x a to the power n minus 1 e to the power ax plus n square minus n a to the power n minus 2 e to the power ax. This is the answer. Now come to the second example. Y equals to e to the power minus x cos x. Then prove that y4 plus 4y equals to 0. y1 equals to minus e to the power minus x cos x minus e to the power minus x sin x equals to minus e to the power minus x cos x plus sin x. Similarly we get y4 equals to minus 4 e to the power minus x cos x. Then y4 plus 4y equals to minus 4 e to the power minus x cos x plus 4 into e to the power minus x cos x equals to 0. Proved. Next example. Y equals to a cos log x plus b sin log x. Then prove that x square y2 plus y1 x plus y equals to 0 and x square yn plus 2 plus 2n plus 1 x yn plus 1 plus n square plus 1 yn equals to 0. Similar as above example, differentiating with respect to x we get y1 equals to minus a by x sin log x plus b by x cos log x. Then xy1 equals to b cos log x minus a sin log x. Again differentiating with respect to x we get xy2 plus y1 equals to minus sin log x b by x plus a by x cos log x. Then x square y2 plus xy1 plus y equals to 0. Differentiating n times with respect to x, we get x square y2 in the second bracket n, that is n times derivative, plus xy1 n times derivative plus yn equals to 0. Applying the Leibniz rule, nc0 yn plus 2x square plus nc1 yn plus 1 2x plus nc2 yn into 2 plus nc0 yn plus 1 into x nc1 yn plus yn equals to 0. Or 1 into x square yn plus 2 plus n into 2x plus yn plus 1 plus n into n minus 1 by 2 into 2 yn plus 1 into x into yn plus 1 plus n into yn plus yn equals to 0. Solving, we get x square yn plus 2 plus twice n plus 1 into x yn plus 1 plus n square plus yn equals to 0. This is our answer. Come to the next example. Here y equals to 1 by root over of 1 plus 2x. Then prove that 1 plus 2x yn plus 1 plus twice n plus 1 into yn equals to 0. We write it in this form: y into root over of 1 plus 2x equals to 1. Then differentiating with respect to x, we get root over of 1 plus 2x into y1 plus y by root over of 1 plus 2x equals to 0. Solving, we get 1 plus 2x into y1 plus y equals to 0. Then differentiating n times with respect to x using Leibniz theorem, we get 1 plus 2x y1 n times plus yn equals to 0, or 1 plus 2x into yn plus 1 plus n into 2 into yn plus 2n equals to 0. Solving, we get 1 plus 2x yn plus 1 plus twice n plus 1 into yn equals to 0. Proved. Come to the next example. Here given y equals to x to the power n minus 1 log x, then find yn equals to what? Now y1 equals to n minus 1 log x into x to the power n minus 2 plus x to the power n minus 1 into 1 by x. Then xy1 equals to n minus 1 log x plus 1 into x to the power n minus 1. xy1 equals to n minus 1 x to the power n minus 1 log x plus x to the power n minus 1. Now xy1 minus n minus 1 into y equals to x to the power n minus 1. Differentiating n minus 1 times with respect to x, we get xy1 n minus 1 minus n minus 1 y n minus 1 times equals to factorial n minus 1, as n times of derivative of x to the power n minus 1 is factorial n minus 1. By Leibniz theorem, we get xyn plus n minus 1 yn minus 1 minus n minus 1 yn minus 1 equals to factorial n minus 1. So yn equals to factorial n minus 1 by x. This is our answer. Our next example is y equals to sin m sin inverse x. Then prove that 1 minus x square y2 minus xy1 plus m square y equals to 0. Then differentiating with respect to x, we get y1 equals to m cos m sin inverse x into 1 by root over of 1 minus x square. Then multiplying this with this, we get root over of 1 minus x square y1 equals to m cos m sin inverse x. Again differentiating, we get root over of 1 minus x square into y2 plus y1 into half into 1 by root over of 1 minus x square into minus 2x equals to minus m square sin m sin inverse x into 1 by root over of 1 minus x square. Then 1 minus x square into y2 minus x y1 plus m square y equal to 0. Proved. Next example, y equals to sin inverse x by root over of 1 minus x square. Prove that 1 minus x square into y2 minus 3x y1 minus y equals to 0. And second question is 1 minus x square into yn plus 2 minus twice n plus 3 into x yn plus 1 minus n plus 1 whole square yn equals to 0. First step is root over of 1 minus x square y equals to sin inverse x. Then differentiating, we get root over of 1 minus x square y1 plus 1 by 2 into 1 by root over of 1 minus x square into minus 2x into y equals to 1 by root over of 1 minus x square. Then 1 minus x square into y1 minus xy equals to 1. Again differentiating, we get 1 minus x square into y2 plus minus 2x y1 minus xy1 minus y equals to 0. Then 1 minus x square y2 minus 3 xy1 minus y equals to 0. Number A equation is proved. For second part, we again differentiating n times with respect to x. Then we get by Leibniz theorem 1 minus x square into yn plus 2 plus n into minus 2x into yn plus 1 plus n into n minus 1 by factorial 2 into minus 2 yn minus 3x yn plus 1 minus 3n yn minus yn equals to 0. So we get 1 minus x square into yn plus 2 minus twice n plus 3 into x into yn plus 1 plus minus n square plus n minus 3n minus 1 into yn equals to 0. Then we get 1 minus x square yn plus 2 minus twice n plus 3 into x yn minus n plus 1 minus n plus 1 whole square yn equals to 0. Then the second part, that is part B part, is proved. So here is my topic and this is my last example for today. Next day I upload another video on this topic. If you find my video is helpful for you, please like and share with your friends and also subscribe our channel for this type of video notification. Thank you.